Hello everyone and welcome to Blockchain Part 5 video on Intellipaat. Now before we discuss our today's agenda, do not forget to hit the subscribe button and click the bell icon. So first we will discuss about what is needed for consensus. Moving ahead, we will learn about basic parameters of a consensus mechanism. Then we will also discuss about proof of stake algorithm. Then we will learn about sidechains. Moving ahead, we will also discuss about what sidechains offer. And at the end, we are going to conclude our session with discussing the blockchain types.
So, the basic acceptance of laws, rules, and norms to decide a transaction should be part of your consensus mechanism. And similarly, the common acceptance of industry and institution that applies these laws and rules should also be considered while designing and developing the rules and algorithms for writing consensus mechanisms. So, in short, in layman term, if I explain, so consensus should include your all business logics, conditions, and all scenarios during any financial transaction or any business that your organization is doing and for which you are developing the blockchain consensus mechanism. So while designing consensus mechanism, what should be basic parameters and how these should be handled, that we will be learning in this slide. First parameter should be your decentralized mechanism. So as we know, while working on consensus, we are dealing with decentralized ledger, say blockchain. So a single central authority must not provide any decision finality. It should be designed and should be decided from consensus itself. Second parameter should be your quorum architecture. Nodes exchange messages in predefined mechanism, which may include stages or tiers. So that what does this mean? This means every node that is transacting in the blockchain should follow certain predefined steps, and any node deviating from this should be considered as a bad node and removed from the transaction. Third, validation. It provides means to verify the participating identities, including your validators as well. So suppose your transaction is started from a peer node A and he is trying to send some bitcoins to recipient or peer node B. So the consensus mechanism should be written in a way that it is able to identify the identity of participants participating in sender and receiver mechanism of Bitcoin and should validate having the information from the transaction itself. Without validation, none of the node or transaction will be recorded in the blockchain. Fourth parameter that should be considered by developing your consensus mechanism is integrity. So as you all know, it enforces the authentication of the transaction, integrity, and validation. So any transaction should be authenticated from the consensus nodes or validator nodes, and then only they should be recorded in the blockchain. Now, fifth parameter would be non-cancellation. This provides means to verify that the supposed sender really sent the message. And this we already learned. This could be done using the private public key pair. The validator node use public key of the sender in order to validate the identity by decrypting the message and using hash mechanisms. Sixth parameter is confidentiality. Your consensus mechanism should provide means to verify that the supposed sender really sent the message and whatever he sent is not changed and not visible to anyone. So the information shared inside the packet or transaction should be kept confidential and should not be visible to any other member inside the network. Your consensus mechanism should also take care of fault endurance. So the network operator should operate the network efficiently and quickly even some node fails or are slow. So what this means is even if your part of network or blockchain is faulty or slow, then the network operation should complete in quick and timely manner. There should not be any delay or loss of transactions. And the last parameter that should be considered while designing your consensus mechanism is fulfillment. That means it considers throughput, liveness, and latency. All should be. That means your consensus mechanism should not be complicated enough or should not be designed in a manner that create unnecessary slowness, complexity, and latency while performing the validations inside the blockchain network. Before moving further, we should understand how consensus mechanism came into picture. What was the history behind it? So the logic came from Byzantine general problem, where Byzantine army has completely encircled the city. The army has many divisions, and each division has a general. This story we have already heard. Some of you have already heard many times while learning some mathematical problems or while learning your algorithms. The same idea has been derived from again Byzantine general problem here in order to write your consensus mechanisms. So the actual story was like the army has many divisions and each division has a general when they encircled a Byzantine city, and the generals were dependent on communicating between each other, between their lieutenants within their division by exchanging the messages. So they were not able to communicate directly. The lieutenants were helping within their division to pass the messages to their generals, and this is how they were communicating. All the generals or commanders have to agree upon one of the two plans of action. That means exact time to attack all at once, or if faced by fierce resistance, then the time to retreat all at once. So the army cannot hold on forever. If the attack or retreat is without full strength, then it means only one thing: unacceptable, brutal defeat. So everyone had to be trustful and work in coordinated manner. When it was time to attack, they should be attacking with the with their full force and full strength without deviating from the rule decided. And if there was time to hold back, then they also should be doing it full strength. So complete agreement was required and complete action was required from whole force. So results: if no, in order to succeed, two-thirds of the generals needed to be loyal to the army. If the amount goes less, that means if more than one-third generals are in disagreement, then there were likely chances to get defeated or failed during the war. So, what was the solution to this problem? How they had to decide that their generals are trustful and trustworthy. They are not going to be deviate from the rules decided in order to get succeeded during the war. The practical Byzantine fault tolerance algorithm (PBFT), which is used to establish consensus in blockchain systems, is only one of those potential solutions that were expected to help the generals and the army to get in more than two-thirds of consensus during any attack and get success during the any kind of attack they were moving upon. What was PBFT? So the solution came in 1999 when Miguel Castro and Barbara Liskov introduced a PBFT algorithm. PBFT can process an enormous number of direct peer-to-peer messages with minimal latency. How it works? Asynchronous distributed system where nodes are connected by a network. Byzantine failure model was faulty nodes behave arbitrarily. So cryptographic techniques to prevent spoofing and replace and to detect corrupted messages were also enforced in this algorithm, and there was a plan to have a very strong advisory in order to get two-thirds or more than two-thirds of consensus and avoiding fault and misbehavior of nodes, or you can say generals, during the message communication. This method of establishing consensus required less effort than other methods. What was actually happening? Each node, the whole piece of army, was arranged in form of a connected network. The peers nodes were connected in a manner like they were not connected to only one of the node. Nodes were interconnected with each other. So if some nodes start misbehaving or arbitrarily, then other nodes were able to pass the message to the connected nodes. So in this way, the generals were sure that the information they are getting is authentic and all the nodes are in sync. So this way of transmission was really fast, reliable, and was helping to attain a significant amount of consensus in less amount of time. So the propagation was happening through connected nodes. Now, the other consensus mechanism that we can use inside blockchain is proof of stake. Proof of stake, like proof of work, is a category of consensus algorithm for public blockchains that depend on a validator's economic stake in the network. Newer kind of a consensus algorithm, it was introduced considering the drawbacks of proof of work where energy consumption and time consumption was very high. And in order to succeed and become a winning block, the participating validators has to invest huge amount of energy as part of solving complicated problems. It was pioneered by Peercoin in 2011. Now, due to this, many versions exist for this proof of stake consensus mechanism, out of which some are NXT, Tendermint, Flying Fox, etc. Your chance of being picked to create the next block depends on the fraction of coins in the system you own. As the name suggests, the more coin you have, more chance of getting a chance to create a new block will be given to you. So this mechanism helps deciding the winner node on the base of a stake he already has. And in this way, the nodes do not need to solve complex problem. in order to win the situation and create the new blocks. And this really helps saving the energy and resources during any new block creation, which is a frequent mechanism, a frequent step taken in any blockchain. A participant with nothing to lose has no reason not to behave badly. This is called nothing at stake problem. That means since it is really transparent that the node with required amount of stake. So in this way, since none of the nodes required to solve complex problems and get rewarded, so they cannot cheat the system by misbehaving and try creating the false results or false solutions to the given problems. The validators or winners are clearly picked from the available stake, and in this way they can help to creating the new blocks. So as of now, since we already know what is proof of work and proof of stake, so let's have a glimpse like how they differs in terms of each other. In proof of work, the probability of mining a block depends on the amount of work a miner does. That means he need to find a solution for the given problem, and all the competing nodes are working to solve the same problem and find a particular number x or any number that is the end result of the solution. Since this requires solving more complex problems, it requires more energy than proof of stake. And one example is mining, which uses computer cycle time to validate new transactions. So mining of new blocks, as we already discussed, is using computer cycle time to validate new transactions. And every transaction new mining is generated. Sorry, every block through new mining is generated every 10 minutes in Bitcoin. That we already seen. So stakeholders in proof of stake validate new blocks by utilizing their share of coins on the network. So the validators nodes actually work on the share of the coins they have in the network, and that is called stake in proof of stake consensus mechanism. The first example of proof of stake was peer coin. A user would need to own a majority of all coins in order to attack the network. What this means is this mechanism helps any node behaving badly and retrieving them, and because they need to have majority of coins available in the Bitcoin or blockchain network in order to attack the network. Since at a single point of time, none of the node can have the majority of coins to alone attack the network and create their own nodes. They will not be able to cheat the system or hack the system at any moment of time. So this way we can see the proof of stake, again a very good algorithm or consensus mechanism that can utilize less amount of energy than your proof of work and still able to make system cheat proof and avoid hacking of the system from the bad nodes inside the system. So this was all about this fourth session of delving into blockchain, where we discussed consensus mechanism, how it works, what are the basic parameters, and what is proof of stake and how it differs from proof of work. What are these sidechains? Sidechains are separate blockchains which is connected to other blockchains through the use of two-way peg, which allow transfer of digital coins or assets between blockchains at a fixed or otherwise deterministic exchange rate. If you can see from the figure, various sidechains are existing along main blockchain and giving two-directional arrow that allows transfer of bitcoins or digital coins or tokens between these sidechains and within main blockchain. These blockchains or sidechains, you can say, serve various purposes. Like this one sidechain can be used for beta releases before making it main branch of existing blockchain. Beta releases can be used to test the release before making it part of main release of blockchain. Similarly, there could exist sidechains of sidechains even, and these can serve different purposes. Even this can be used as microservices like micropayments. This can be used for R&D purposes, research purposes, and serving various other needs that an organization need. Sidechain extensions can be done in following manners. They can be used as native asset issuance. They can be used as smart contracts. They can be used as real-world property registries, and they can be used to secure handles. Sidechains can have other sidechains for things like micropayments. They allow for experimentation, pre-release versions of future sidechains, or even a beta version of Bitcoin itself. So, what all the advantages are that sidechain offers? Sidechains enhances blockchain performance and privacy protections. How they do this? When you have a different requirement, you want to test any new blockchain release. If you have any other service integration with, you can do it using sidechain without interrupting the existing main blockchain network. So your existing blockchain can keep serving the request the way it is doing as of now, and your new sidechains can be used to serve your special needs and special requirements that may not be needed as part of the main blockchain. Second, what they offer is sidechaining is any mechanism that allows tokens from one blockchain to be securely used within a complete separate blockchain, but still moved back to the original chain if necessary. Your sidechains are part of your main blockchain. They allow a point where bitcoins or other tokens can flow from main blockchain to sidechains and from sidechains to blockchain, vice versa. So, existing blockchain tokens can be used and utilized whenever required in the new transaction in sidechain as well. Sidechains can have other sidechains for also as micropayment as we have seen in the above diagram. So these are the benefits of sidechains that offer with the when existing with the main blockchain. Transfer of assets inside block sidechains. How it happens? Let's take an example of root rug stock in order to transfer asset from one chain to another. So how it happens? The step one, a user on the parent first has to send their coin to a special output address that is of root stock address, and then coin will consequently become locked and unspendable. So the moment main blockchain start sharing his blockchain, that amount of coin, amount of asset is locked inside the main blockchain and becomes unusable for that amount of time inside the network. So it will not be shown in the main balance of the wallet of that node. Then the next step becomes after the transaction completes, the SPV then confirms it across the chains. So what does happen? When the transaction is completed, the blockchain node is freed up that amount of transaction and start reflecting in the network as its main available balance. So this is all happening by using the transaction and the coins available in the main blockchain, and that was used for transaction inside the other sidechain network. After waiting out a contest period, which is just a secondary method to help preventing double spending, the equivalent amount will be credited and spendable on the sidechain and vice versa once the transaction is completed. So when SPV confirms, where SPV stands for simple payment verification across the chains, then transaction is considered complete and the amount is again returned back to the and start showing in the node's wallet. Sidechains have their own miners to help protect them from nefarious actors and attack against the network. So, in short, we can say that sidechains also are small blockchains that have their own miners and ensure the integrity and validity and authenticity of any transaction coming across in the network. So, what are the platforms for implementing blockchain? Nowadays, since blockchain has evolved a lot in last one decade, there are many developers, organizations, investors, and ideas generators have evolved with various kind of blockchain platforms. So nowadays there exist multiple blockchain with multiple facilities, multiple advantages, and multiple features. Out of which we will be discussing about few that constitute important area inside blockchain terminology. The first one is Ethereum. We all might have heard about term Ethereum. It is a public permissionless blockchain, a blockchain platform that lets anyone build and use decentralized applications that run on a blockchain technology. Like Bitcoin, no one controls or owns Ethereum. It is a public permissionless blockchain network where everyone can participate and transact and earn token or currency. Then comes multi-chain. This is again a blockchain platform for the creation and deployment of private blockchains, permissioned blockchains. So it can be used either within or between organizations as well. So this is permission. So this is permission and it requires permission in order to transact and participate in the existing blockchain multi-chain network. Hydra chain, a joint developed effort of Brainbot Technologies and the Ethereum project. It supports the creation of scalable blockchain based applications. Then comes Hyperledger. This is again becoming very much famous in blockchain technologies. It is an open source collaborative effort created to advance cross industry blockchain technologies. It is supported by Intel and open source Linux Foundation. Then OpenChain. OpenChain is again a blockchain platform that is well suited for organizations wishing to issue and manage digital assets. It takes a different approach than the standard Bitcoin approach on implementing blockchain. Then IBM Bluemix. Being a giant player, IBM also allows and have their own blockchain network and platform that is on IBM Bluemix, built on top of Hyperledger project, and it offers additional security and infrastructure facilities for enterprises. So IBM are preparing blockchain in such a manner that they are enterprise ready and can be directly used by enterprises and financial or other organizations to start and migrate their existing applications to blockchain network in order to facilitate and utilize the features and benefits provided by blockchain. There is another kind of blockchain network exists that is called chain, yet another and well suited for financial applications based on chain core, which is an enterprise software product. Then IOTA is another blockchain That is a revolutionary new blockless distributed ledger which is scalable, lightweight, and for the first time ever makes it possible to transfer values without any fees. If we see, the above blockchain platforms take some amount of fees in one form or other, while IOTA helps, that is again a blockless distributed ledger and do not take any fees for doing transaction over blockchain network. There are various more. BigchainDB, an open source system that starts with a big data distributed database and then adds blockchain characteristics, decentralized control, immutability, and the transfer of digital assets. Then comes Corda. It is again a digital ledger platform which pluggable consensus. So multiple consensus can be used here, plugged with the blockchain and utilized and simply forms a different kind of blockchain with flexibility of adding pluggable consensus. You can anytime change the consensus algorithm by from proof of work to proof of stake, from PBFT, from POET. So it provides various options of using multiple consensus algorithms. Quorum, an open source digital ledger and smart contract platform based on Ethereum, that is customized Ethereum platform using distributed ledger and smart contract. Stellar, an open source distributed payment infrastructure that provides RESTful HTTP API servers which connect to Stellar Core, the backbone of the Stellar network, and help you giving a blockchain network where you can utilize and do your transactions related to your business need. There is another kind of consensus algorithm was introduced by Intel basis on the an analysis on the existing block proof of work and other mechanisms that were really time consuming and resource consuming and resulting loss of energy as part of new coins generated inside the bitcoins. So what proof of elapsed time does, how it is having advantages over existing consensus mechanisms. So proof of elapsed time was introduced by Intel and developed its own alternative consensus protocol called proof of elapsed time, which was based on waiting time or idle time of validator nodes. Proof of elapsed time, a Nakamoto-style consensus algorithm that is designed to be production-grade protocol capable of supporting large network populations. It means this was able to give fair chance to all validator nodes in order to create new blocks inside the blockchain in large network populations. POET relies on secure instruction execution to achieve the scaling benefits of a Nakamoto-style consensus algorithm without the power consumption drawbacks of the proof of work algorithm. As we all know that proof of work algorithm requires to solve huge complex problems in order to become winner. That was requiring good hardware configuration and huge amount of energy to be spent in order to find solution of the given problem. Basis on this, Intel analyzed that this consensus algorithm is having its own drawbacks and requires a lot of energy to be wasted. So they thought of giving time to all the nodes. For that time, they can sit idle and wait for their term in order to get the chance to create new blocks inside the blockchain network. So that's why it is called proof of elapsed time algorithm, because every node after creation of new block was given an idle time for which they can stay in sleep mode, and then when their time expires, their elapsed time expires, they are given a chance to create new blocks and fair chances given to every block inside the every validator node inside the blockchain. POET example is used by Hyperledger Sawtooth, which is again Intel blockchain network. POET simulator which provides POET style consensus on any type of hardware including a virtualized cloud environment. So this consensus algorithm can be used in any including virtualized cloud environment as well. So what are the advantages? Why we should be using POET over proof of work and other existing PBFT or other consensus mechanisms? For the purpose of achieving distributed consensus efficiently, a good lottery function POET has several characteristics. Fairness. It gives the function should distribute leader election across the broadest possible population of participants. Means all participants, validator nodes participating inside the validation and creation of new block should be given fair chance and equal chance in order to create a new block inside the blockchain. And that is being achieved by proof of elapsed time algorithm. Second was investment. The cost of controlling the leader election process should be proportional to the value gained from it. That means any validator node should not be investing too much resources, too much cost in order to gain a little reward from the system against new block generation. Verification. It should be relatively simple for all the participants to verify that the leader was legitimately selected. Every node should be given a fair chance, and that is what this POET algorithm ensures and helps giving every node a fair chance in order to create new block inside the blockchain network. So this was all about consensus algorithms that we discussed. There are many more existing inside the current blockchain world, and every consensus algorithm is picked depending on the requirement and amount of resources available for creation of blockchain. Definitely, the low cost and efficient algorithm will be picked and used against other available algorithms while selecting any consensus mechanism. Moving to types of blockchain, based on the scenarios and based on the categorization, blockchains are divided into multiple categories and differentiation is based on the current scenarios that are being used. Blockchains can be categorized into permissionless or permission blockchains. Simultaneously, they can also be categorized as public and private blockchain. Let's see how this is being done. Blockchain types. Public blockchain. A blockchain that is public is a decentralized, distributed and public digital ledger that is used to record transactions across many computers so that the record cannot be altered retroactively without the alteration of all subsequent blocks and the collision of the network. Example, Bitcoin, Ethereum, Dash, Factom. Just to explain, blockchain, the public blockchain are accessible to everyone. Anyone from public can come join the network and start doing the transactions. They do not have restrictions in order to create new blocks and in order to participate in the blockchain network. Obviously, the consensus mechanism will be there in order to validate the newly created blocks, and before committing them, they should be validated. Second type is private blockchain. As the name suggests, these are private blockchain network that requires an invitation and must be validated by either the network starter or by a set of rules put in the place by the network starter. So they have well organized algorithms written that whenever a new joiners come to the blockchain network, they are validated, they give certain access that is again restricted, and they need to perform their transaction accordingly. Examples, multi-chain and block stack. These are certain example of private blockchain networks. The third type also exists that has more restrictions than these two, that is called consortium. Controlled by a consortium of members, only predefined set of nodes have access to write and read the data of block. Example, Ripple, R3 and Hyperledger 1.0. These are really well suited for organizations that want to control their blockchain network and perform transactions in their own way. Second type of categorization of blockchain is permission and permissionless blockchains. Properly permissioned blockchain network differs from unpermissioned blockchain network solely based on the access control layer built into blockchain nodes. So, as the name suggests, permissioned blockchains are secure and give limited permissions to the miners and the joining peers inside the nodes. Every peer participating inside the blockchain network in permission blockchain is given certain amount of permissions only in order to perform certain actions. While in unpermissioned blockchains, peer nodes are free to do any kind of transactions without having any restriction and generate new blocks. Mind it that the consensus mechanism will always be there inside blockchain for validation and creation of new blocks, that is mining. So in permissionless, since the network is open, anyone can participate and contribute in the consensus, hence it is called permissionless blockchain. Versus the permission blockchain where that restricts the actor who can contribute to the consensus of the system state, hence this is called permission. You have any actor need to behave within the permission assigned to it, and he can result in actions according to that only. So based on these, public and private blockchains can be differentiated and categorized or bifurcated into as per the below chart and against below properties. Like if we talk about access, then public blockchains are always available publicly and anyone from public peer can read and write the data inside the distributed ledgers. In private, only nodes having access can write or read to the distributed ledgers. Speed. Since in public networks, multiple nodes can join at any time and the number of nodes inside the public blockchain network are always high because of its openness, so transaction amount is also again high, and in turn this lowers the performance and efficiency of the overall blockchain network. Against to this, private blockchain networks are faster and because they have low number of nodes and peers participating inside the blockchain networks. Security. If we talk about security, private blockchains, security is provided by proof of work and proof of stake that we have already discussed, while in private, it is provided by the pre-approved participants. Next comes identity. So in public blockchain, rather using direct identity, anonymous or pseudonymous identities are used. We have already discussed what anonymous and pseudonymous identities are. Anonymous identities are where you will never be identifying who is the sender, who is the participant participating in the transactions. While in pseudonymous, pseudo identities are used, rather using direct identities, like your employee ID is your pseudo identity, or your candidate ID, voter ID, these are all pseudo-identities using which someone identifies you in public blockchain networks. Despite of this, in private blockchains, pre-approved identities are used. Any participant that is participating or created inside private blockchain is given an unique identity, and that is already approved and used in all transactions initiated by him and to validate him by the validators. Assets. Native assets are used in public blocks, and in private blockchains, any asset can be used as native asset in order to store the transactions. So this was all comparison about between public and private blockchains. So based on the four criteria, we divided the blockchains into public, private, and permissionless blockchains. These can be again summed up in order to create four categories of blockchains, that is permissionless public, permissionless private, and permission private. Out of which permissionless public blockchain is very much open and most accessible to the any member or any outsiders that can participate inside the blockchain and do start transactions. Anyone can download the protocol and validate the transaction and create new blocks. Example of this kind of blockchains are Bitcoin, Ethereum, and Zcash. While in permission blockchain, permissions are included for the peers that are participating in the network, and it works on the proof of stake consensus algorithm. Ethereum after Casper is an example of permission blockchain, and anyone who meets the certain predefined criteria can only download the protocol and validate transactions. That means you have to give explicit permission to the members that are contesting or participating in blockchain creation. Then comes permissionless private. That has certain restrictions, but there is no specific permission granted. All the nodes are given public access and that are private to the organization itself. So in short, we can say all nodes that are part of the blockchain are interacting inside the private blockchain and all have all the permissions required to initiate and transact inside the blockchain. Then comes most secure blockchain, that is permission private blockchain. This is private to an organization, consortium, and has different permissions according to which all actors interact within the blockchain network. PBA and IPDB are example of permissionless blockchain private blockchain network, and PBFT and multi-signature are example of permission private blockchain network. So if we see in this diagram, so the public to private and the entities decrease from top to bottom, and if we talk about permission, then it goes again from validators to from permission to permissionless blockchains. Until then, see you soon.
Just a quick info, guys. Intellipaat provides blockchain certification training mentored by industry experts, the course link of which is given in the description below.